Manually entering prices at the supermarket checkout, this is out. Whether it's milk, butter or bread, everything is now scanned. Even when sending out packages, everything comes back to the one-dimensional barcode. But these systems are very limited. There are just 20 number symbols in the code. At the beginning of the 1990s, two Japanese scientists sought to change this. With a small graphical pattern, they changed our world. Masahiro Hara and Takayuki Nagaya invented the 2D code, also known as QR code. At that time, you used computers in sales and production. The storage capacity of one-dimensional barcodes just wasn't enough, so I started working on a new generation of barcode. In 1992, Hara was working on the development of automatic data collection devices. He first tried to expand the capacity of one-dimensional barcode readers, but that still was not much better. Along with some computer specialists, Takayuki Nagaya dreamt about the invention of a two-dimensional code. One of the main problems in the beginning was that it took too long for the code reader to detect the position, size and angle of 2D codes. Hara desperately sought a solution. One day, while he was out for a walk, Hara saw a skyscraper with different patterns, and suddenly it clicked. At the top of the building there was a geometric pattern. That gave me the idea to create a 2D code that used a pattern. Hara and Nagaya began to work on the construction of a usable pattern. They discovered that a code reader can recognize the information faster if the patterns are attached to the corners, on 3 corners of the code. The advantage of using 3 corners over 4 is that only a right angle is formed, so we can see the size and orientation of the code easier. How and where the codes were to be attached was now clear, but it still lacked a distinctive pattern. Because if similar symbols are too close together, the code reader mixes up the patterns at the corners. Hara analyzed thousands of different characters, symbols and fonts from around the world. He used a device that he had specially developed for it. My idea was just to look through all the fonts, signs and symbols that existed to find a single symbol that is not used anywhere in the world. Hara worked tirelessly day and night. After 3 months, he finally found the solution. He actually discovered a pattern that is not used anywhere else in the world. While I was evaluating all of the symbols and characters, I discovered a unique black and white pattern, which I then used for my code. With one problem solved, the next was to figure out what would happen if a code was damaged and misinformation was produced. There must be a way to correct such errors on the spot. Again, Nagaya went on the hunt for the right formula. There were no computer programs around that could make these kinds of calculations. He tried countless times until he finally found the answer. There were error correction codes on DVDs and CDs. I optimized this for the 2D codes. This helped me reduce the error rate to 1,000th and generate the correct information from faulty codes. After 2 years of research, it was finished. The two-dimensional barcode was born. It processed 350 times more information than its one-dimensional predecessor. In addition to its original application in production and logistics, it is now used in many different areas. 2D codes on posters, for example, guide users directly to digital content. This is one good reason to nominate Hara and his team for the European Inventor Award. I feel very honored to be nominated for this award, and I'm very pleased that people are using our 2D code throughout the world. 2D technology is really interesting, and I hope that more and more people will use it. It would be a great acknowledgement of their work if Hara and Nagaya received the big prize at the awards ceremony in Berlin.